All right, this is the final FRQ, for 2014. So we're gonna go over this one. I know I when I look and I see that I'm about to do a slope field question, I kind of get excited because I know there's gonna be a couple of easy little chunks that I have to do. I also know that part 3 or part C is coming. And part C is hard because it involves separating variables, integrating two sides, and then at the end, using the initial condition to find the C value. So that's kind of the essence. There's about a 150% chance that that's going to be on every AP FRQ test ever. Somewhere it's coming. So let's do this one. I went ahead and printed out the solution page so we could talk about it. And it looks a little different than this because they wanted to squeeze it all in one page. So there it is. Pretty cool, huh? So let's go over it and make sure that everyone gets their questions answered. So first of all, they actually gave you the formula for the slope. That's super nice. So if I wanted to know the slope at 2, 0, I would plug in a 2 and a 0. And then that would tell me what the slope is there. Then they also said, hey, draw me, part A says, draw me the expression or the equation if it goes through the point 0, 1. So this point 0, 1, they want you to start at. So 0, 1 is right here. Make sure you realize this is a 3. So this is 2 and 1 and 2 and 1. So make sure you've labeled or you understand like this is not, each square is not a line. Each square is not a line. Huh, whatever. So with that said, I just follow the slope. Make sure you don't cross any of these lines as you draw them. So don't like have it go through here where if this is the slope, remember, if this is the slope, at the most it's tangent to that. So you can't cross one of these slope lines. You don't have to be perfect, but you do have to be pretty accurate as to where it's going. And by the way, you get a whole point for that. Nice. 1/4 of the way there. Here we go. Next one, the next part down here is pretty straightforward. It says, hey, write the equation of the tangent line. So if you remember, dy dx up top was 3 minus y cosine x. So if I'm going to find the tangent line at 0, 1, then I'm going to put a 1 in for y and a 0 in for cosine. So that's where you get 3 minus 1 times the cosine of 0. So that's where they get this answer right here. 3 minus 1 times cosine of 0 is 2 times cosine 0. Cosine of 0 is 1. So the slope is 2. So now all I have to do is write the equation. They just jump straight to slope-intercept form because the point 0, 1 is the y-intercept. You could still do y minus 1 equals 2x minus 0. You still get 2x plus 1. Doesn't matter. The second part of the question says approximate the answer at point 2. So that means I take my equation right here. I plug in a point 2. So 2x plus 1 is 1.4. So I get a point for my tangent line and a point for plugging in point 2. Awesome. All right, buckle in. Part C is about to go down. There are 6 points all happening right here. Here we go. So part C says, tell me what the original name of this function is. Go find yourself f of x. So if I have dy dx and I have to turn it into f of x, I have to take the integral. So if you give me the derivative, I have to take the integral of it to turn dy dx back into the original y. So the first step is to take my original equations and separate the variables, which means I take these y's, I put them underneath the y's, and I take the x's and I put it over here with the x's. It's worth a point, by the way. I then have to take the antiderivative. I have to take the integral of 1 over this. Remember, it's a negative y. So if I used u substitution, there would be a minus sign out in front of the ln. So it'd be the ln absolute value 3 minus x, but there's a minus sign out in front because there was a minus y. There's that little mini chain rule, u substitution thing that gets us. On this side, the integral of cosine is sine. Hopefully you didn't write negative sign. And you can check because the derivative of sine is cosine. So the integral of cosine is sine. because the derivative of sine is cosine, kind of like that. All right, so this is what we got. I then have to, by the way, that's worth 2 points. Make sure you got the plus c right here. All right, so now I'm going to find c. So the way I find c is I know what my point is that I'm looking at. Remember, my initial condition is 0, 1. So I'm going to put a 0 in for x. I'm going to put a 1 in for y. And I got negative ln of 2 equals the sine of 0 plus c. Sine of 0 is 0, y'all. So c is negative ln of 2. So that is going to give me my actual function. By the way, that is these 2 points here. I think this constant of integration, I think that is this stage right here where you actually find out what it is. I don't know, because it says initial condition, which implies that would be that also. So I'm assuming these 2 points are pretty much when I went from here to there. I don't know. All right. Next stage says it solves for y. So all this other stuff, this complicated stuff, is only worth 1 point. However, if you solve for y, this is what it would look like. Blah, 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 blah. Oh, because I'm looking at the point 0, 1 right here, this value, what I would plug in for y, is going to be positive. So I don't really need the absolute value signs. It's just 3 minus y. So that means the ln of 3 minus y, so I'll use e to both sides. So I would just use the e value here. And that would leave me with, what did they do? So you see the minus sign here, so they must have used this minus sign first. So maybe their first step in this problem right here was to say, you know what, let's move this minus sign out, and let's say the ln of 3 minus y equals negative sine x plus ln of 2. So now, when I use my e value, I'm going to break this up, and I'm going to just get this on this side, and then over here, remember, I have e to the negative sine of x times, because it's plus, right? Plus turns into times e to the ln of 2. And of course, e to the ln of 2 is just 2. So that is where this is coming from. So 3 minus y, these cancel, equals that, and then you add 3 to both sides, and that's it. So if this is your solution, or some form of this is your solution, you get the final point. All right, 2014 done. Enjoy that. I think we're probably going to jump to 2016 next. I don't know. But good luck. See you next time.